Let's talk about finding equilibria and determining stability. For the autonomous differential equation dy dt equals g of y, remember that just means stuff with no t's. To find equilibria, solve dy dt equals 0. Why are we doing that? Well, remember we said that equilibria happen where you have a zero derivative, which is where the phase plot crosses the horizontal axis. So you're going to set the derivative equal to 0. In other words, the formula for the derivative equal to 0. That'll get you the equilibria. Now, to determine stability, we're going to construct the phase plot, put the arrows in on the horizontal axis, and then we'll use the arrows to determine whether each equilibrium is stable or unstable. By the way, you can ignore the local stability criterion on page 434 of the textbook. We're not going to use it. For example, let's find all equilibria for the autonomous differential equation y prime equals y minus 1 times y squared minus 5. Then we'll construct the phase plot and use that to determine which equilibria are stable and which are unstable. So setting the formula for the derivative equal to 0, that gives me either y minus 1 equals 0 or y squared minus 5 equals 0. Let's see, if y minus 1 equals 0, y must be 1. If y squared minus 5 equals 0, y squared must be 5. So y itself would be plus or minus the square root of 5. So those are our equilibria. In fact, let me put the little hats on them to emphasize that we're talking about equilibrium solutions here. We've got our equilibrium solutions. Now we need to know which are stable and unstable. And for that, we need the phase plot. This is a pretty standard polynomial graph, so we should be able to graph it. But my purpose here is not to review graphing, so let's be efficient and use technology instead of producing a lot of graphs by hand. You can use any graphing software you want to use, or do things by hand when you can, but I'm over here at geogebra.org/calculator because I kind of like their grapher. We only have to put in the right-hand side of what we're graphing, which is y minus 1 times y squared minus 5, but we can't use y. It won't understand that. We've got to use x's instead, just for the purpose of graphing this. So I'll have x minus 1, x squared minus 5. And here I get the graph. I'm going to clean it up a little bit. I want to zoom out a little. And I don't really need to see the grid. I haven't found a way to save the image, so I'm going to do a screenshot. I'm going to go to the folder where I have the screenshot, and I'm going to give it a better name because I'm ending up with an awful lot of these phase plots in my chapter 7 folder. So I need to know which one is which. And what I do is I write phase plots and then I put in the right-hand side of the equation that I phase plotted. Back to the lecture notes, I will insert the picture I've saved. Ooh, that's huge. Let's have it not take up my entire page. Let's be sure to label our axes. We have y and y prime. And let's also label these equilibrium points. By the way, notice that I really did need to solve for y hat. In other words, looking at the phase plot would not tell me that two of those x-intercepts are at root 5 and minus root 5. The best I could do would be to approximate them, and we want to know the exact value. Let's put the little arrows in where the graph is above the x-axis. The y value will be increasing. Where it's below the x-axis, decreasing. And here's a spot where it's increasing, and then to the left of minus root 5, it's decreasing. So we can see that the equilibrium solution y hat equals negative root 5 is unstable because the arrows are pointing away from it. Y hat equals 1 is stable because the arrows are pointing towards it. And y hat equals positive square root of 5 is unstable. Again, the arrows are pointing away from that one. This is probably a good time to give you a chance to check your understanding or to build your understanding. So before you watch the next video, please find all equilibria for the autonomous differential equation y prime equals y plus 2, the quantity squared, times y squared minus 6. Construct the phase plot and determine which equilibria are stable and which are unstable. To construct the phase plot, you can either use your knowledge of polynomial graphing to graph this, or you can go to GeoGebra and obtain the graph there, and once you've got the graph there, or wherever you want to get the graph from, you can either paste it into the document, or you can just sketch it by hand. Remember to label your axes and to put in the little arrows. And I will go over this with you at the beginning of the next video.